Okay, so here we're back to one of our contextualized examples. In a particular experiment, the length of a metal bar is measured many times. The measured values are distributed approximately normally with a mean of 1.340 meters and a standard deviation of 0.021 meters. So the length is normal with a mean of 1.340 and a standard deviation of 0.021. Find the probabilities that any one measured value exceeds 1.370. So we have a mean of 1.340, and for this first one I want the probability that the length exceeds 1.37. So 1.37 is this side, so I'm interested in that area there. So when I'm going into my calculator now, I'm going to 7. I'm wanting to find the area, so it's normal cumulative, 2. Lower value, 1.370. Upper, 1 times 10 to the 99. The standard deviation is 0.021. The mean is 1.340, giving me the probability of selecting a bar measured greater than 1.370 is 0.077. Part 2. The probability that it lies between 1.310 and 1.370. So if I draw myself a little sketch just to make sure I'm happy with what I'm looking for, it's going to be either side of the mean. I've got this value 1.310, this value 1.370. That's the region I'm searching for. So this time my lower value is going to be 1.31. My upper value 1.37. Mean and standard deviation stay the same. So for that one I've got 0.847. So that one, 0.847. Part 3. So it's the same as that, but with a different set of parameters. So the shading is going to look the same, it's only the boundaries that are different. So for this one, I've got 1.33 is less than L is less than 1.39. So I know the shape of it, I don't need to redraw it. So 0.674. And then the last part of it, find the length L for which the probability that any one measured value is less than L is 0.1. So they're giving me the probability. So this is an inverse. Find the length L for which the probability that any one measured value is less than L is 0.1. So here I'm interested in a less than area, so it's this side because it's quite small, it's 0.1, and I want to find that value there. So the probability that L is less than little l is going to be 0.1. So going back to my menu, 7, now I want to do the inverse normal, which is 3. The area is 0.01. It's carried through the mean and standard deviation from the work we were doing in the cumulative normal. So I'm just going to press equals, and I get that L is 1.313. So I think we're getting up to a sort of exam standard question there, which are asking you to work with finding probabilities and then finding boundary values given probabilities.